two here, right? Right, and so that's big progress, right? So we go back to lab view here, and I go, well, shoot, let's stop this thing. And what do I need to do with these? Well, it looks like I need to take the V of the resistor and divide it by the VR. So, okay. So let's see, I think I need a math. Well, let's see. Actually, these wind up being under numeric. Okay, and under numeric we have at the very top add, subtract, multiply, and divide. Get used all the time. Okay, and then there's a whole bunch of other, by the way, really cool ones in here. And you can get to a whole bunch of others in other places out of here. There's even math constants in here and all kinds of fun stuff. But this is that we can have way too much fun with. But now we're gonna do divide. Now, it's gonna look like a plus sign, right? Because it's fuzzy, but it's division, right? I mean, it's pretty clear on my screen, but it looks like division. What I'm gonna do, I'm gonna take divide, numeric, divide, drag it out here, and take the value of the resistor here, right? And I'm gonna divide that by a constant. And the constant I want to divide is my resistor value, and in my particular case, my resistor value is 12 k ohms, because I picked one that was different than yours. So mine's going to be 12. Now, I could put this in and put 12,000 in there because it is 12,000 ohms, right? But what units am I going to get out of here? In this expression, what units am I going to get out of here? We're working this equation here, so what are my units? Well, they're going to be whatever the units of this is, right? And if I look at my graph here, and all of my data, all of the data on the top here is the R is in kilo ohms. Right, so if I leave my R here in kilo ohms, then the value of R I'm going to get out of here is going to be in kilo ohms, because the voltages are just going to get revolted and just cancel out. Right, so I can put 12,000 in there, then I'm going to wind up multiplying or I'm going to wind up dividing by 1,000 later, and it's kind of like Y. Right, so we do again a little bit of unit analysis, right? Making sure our units are going to match up with the kind of data that we're going to have there. Okay, so looks like I got that. That's going to get me out of here. What am I going to get? I'm going to get the current. So I can, if I really want to be fussy, I can say current. Okay, and then what do I need to do? I need to divide to get resistance, I need to divide the voltage by the current. So I can get another divide in here, right? Get another numeric, another divide. Of course, I could have copied it, but now I want to divide the voltage. I make, darn divisions, not commutative, right? So, okay, I'm going to divide the voltage over here by the current, and I'm going, they're crossing each other, and going to be easy for me to screw that up, but hey, that's what it is.
When you're dividing the order, I mean, what's denominator, what's on the...
Well, what needs to be, the thermistor needs to be on the top, and the top is the top.
Okay.
Numerator's the numerators, bottom's the denominator, right? Right, it's the top divided by the bottom, right? Just like you'd expect, right? Okay, and so I'd kind of like to measure that, so what I'm going to do is I'm going to copy one of these, put it down here, and I'm just going to call this resistance. And by the way, if you really are fussy, you don't like the way they line up, right? There's actually a whole bunch of alignment tools up here, okay, to make everything look good, right? So, okay, so anyway, I have a resistance here. And I could just put this guy over here and say, that's the resistance. Okay, so what have I done? I've done this formula, right? And is that pretty obvious, right? We got the V of the resistor. We're dividing it by my resistance, which in my case is 12 k ohms because that's the resistor I happen to have when I picked it out. And then I'm dividing it, that gives me the current, and I'm dividing the voltage through the thermistor divided by the current through the thermistor, and that's going to get me a resistance. Okay. Now that's how we implement. Now we've actually done quite a bit of data processing here, if you think about it. What did we do? We took 10,000 data points. Well, we took 2,000 data points from each channel, right? There was 1,000 in each channel, and we split them up. We averaged them. We did some mathematics on the results, and we got a resistance. And now we can go look at this, right? We can go run here, and I get a resistance, which it's telling me is about 11.25 k ohms. If I look at my thing in here, 11.25 k ohms would be somewhere between 20 and 25 degrees C. Right? If you just look at the data up here, right? Between there's 12.36 k ohms, there's 10 k ohms, about halfway between, about 22 degrees C. Hey, that doesn't seem to me to be unreasonable.
70 something, 71?
Yeah, something in there, right? I think it's about right. Right? So I'm at least in the ballpark, right? I'm not way off, right? And of course, as I heat it up, what happens? I haven't started heating it up yet. We'll go back to that. I'll heat it up. What happens? Goes down quickly, right? Okay, which is what we expect of this particular thing. So, okay, so no problem, we're getting good data out of this, right? Circuit looks pretty straightforward, doesn't look particularly hard. Only one minor problem, of course, is that we're measuring resistance, and we really want to measure, temperature, right? I mean, that's what it is, it's a temperature sensor. We kind of want to measure temperature. Right? I mean, resistance was cool, but because that's what it does, it changes. It's the thing that changes with temperature, but I really want to measure temperature. Okay. Well, so how am I going to do that? Well, I got this. Yeah. And I'll send this to you, by the way. I'll put it up on Blackboard. You've already got it, but I'll put it up in its own separate file. And I got data here. I got data here. So we could do something that was like,
Look up.
maybe there's a function that would fit that data. Right? You think we could find a function that would fit that data?
One of the X.
Yeah. I mean, it kind of looks, there might be something in there that fits the data, right? Now, there's a little problem with it, right? That we've got temperature on the x-axis and we've got resistance on the y-axis, and we really want it the other way around, right? Because I want temperature as a function of resistance, and right now we have resistance as a function of temperature, right? But we can go play some games with the data. Let's go, how would I ever figure out a function for that? Well, I'd have to go use some sort of mathematical toolkit. Something like MATLAB.
Oh, no.
But I didn't require MATLAB for this class.
No.
Correct.
Probably most of you don't have MATLAB on your computers.
Some of us
Oh,
can.
we're gonna have to do something else then. So what else can we possibly do? Well, what do you have on your computer that'll crank numbers?
Excel.
Okay, so how about, let's say, new blank worksheet. So what am I gonna do? I'm gonna do, is Excel civilized? No, Excel isn't civilized, okay. So let's do something like, I want resistance, right? Yeah, you can't typing with my thumbs again, right? What you get. And then over here, we want temp. Okay, and let's get some data. So let's see, what's my data gonna look like? I'm gonna make it small here, so actually, I can go back and forth. Come on. Where's my Excel? There it is. Come on. Okay. You're not really that small, are you? You are. Okay, well, let's go back, we'll just have to go back and forth between these. Okay, so let's say at 0 degrees C, I have 28.42 ohms. Just, how about somebody reads them off to me? I think Sophie has them, so I'll pick on it. How about we do, at 0 degrees C, and let's do what, 10 degrees C, 20 degrees C, 30 degrees C, 40 degrees C, 50 degrees C. We'll get that should be enough to get us some data there. So this is what, 28 point something ohms. So, oops, wrong one. 0 degrees C was 28.42, 10 was 18.4. Okay, 28.42. And then we have 18.4 for 10.
Yes.
And then 20 is like
12.36.
36. And 30 is
8.22.
8.32.
22.
22, okay. And 40?
5.74.
5.74.
And 4.06.
0.06, and that was 22 for this one here. Okay, so I got data there, right? Like that? Doesn't that look good? Okay, now, am I gonna be happy if you guys enter 5 data points?
No.
No, because we're gonna go all the way from 0 to 100, right? So I expect you to put all the data in from 0 to 100, but there we're gonna do. So now what do we need to do? Well, in Excel, typically what we like to do is we like to plot these things. So let's insert a chart.
Mm-hmm.
And of course, you guys are smart enough to know that the only kinds of charts we ever use in here are scatter charts, XY. If you ever give me one of these line charts here or array charts, I'm going to bleed on your paper. Okay? So, and I'll take one with a nice smooth curve. Why not? Right, just to see where we are. Okay. So I got a perfectly fine chart here, right? We'll make it big. And then I'm going to, let's see, select the data, right? And what do I want? I want to add a series, right? And the series name as well, temp. And I want the X values to be here, right? And I want the Y values to be here, right? And I get a graph that looks like that. Is that what I get? I get up to 50 over here, so these are temperature values over here, and these look like at 4.3 looks like the X values, right? Is that looking right?
Mm-hmm.
Looking right? Okay. So now that's some data. Of course, you'll get more of it, right? So, and now we can, hey, let's see, we'd like to sort of have the function for this. So we can add a trend line. We just right click on it, we can add a trend line, and it gives us some options there. And there's a linear trend. Well, it sure doesn't look linear, right? Okay, well, how about logarithmic? Oh, that that looks pretty good, right? We see the chart, does that look pretty good?
Mhm.
Are you gonna, I mean, I don't think I'm gonna get any better with a with a polynomial might, but it's gonna, no, it's not even as good, right? And moving average one, no, I think I'm gonna have to go logarithmic, okay? And over here, I can actually, at the bottom, I can do something pretty radical like display the equation,
Mhm.
right? And boy, that it gives me an
Equation.
equation, right? And I can, let's see, vertical alignment, yes, come on. Okay. Okay, so anyway, I can also go to the trend line, come on. I can display the R squared value, which is some indication about the variance, how close the line is, and when I have an R squared of 0.998, I'm going, that looks pretty good, right? Okay, so and I also have an expression here that says y is equal to minus 25.63 times the ln of x plus 84.932. Okay, that's an expression for that curve fit. And Excel just did that.
Hmm.
Wasn't that civilized? Think you can make Excel do that?
Yes.
Yeah. I have faith. Okay, so now we get to go enter that. If I have an expression that's gonna get me from what? Well, it's gonna get me from the x-axis here, which is my resistance, right? My 28 down to 4.6. Those are the values that the resistance changes on, and it's gonna turn it into temperature. And it's gonna be pretty close. Right? We believe?
Mhm.
Okay.
It came from a computer.
What's that?
It came from a computer.
Came from a computer. Okay, okay. I'll accept your skepticism there, with well thought. So I suspect that if I clicked on this, there's some place where that I could mess with the font. Yeah, there we go. Let's make the font a little bigger, right? Is that a little better?
Yeah.
You can see the expression there a little better?
Mhm.
Play with the font, right? Okay, so now we go back to lab view and we're going, okay, shoot, we got a nice mathematical expression. Now, what do I need to do? Well, shoot, I gotta, come on, you're not gonna let me minimize you, are you? You're gonna be very stubborn about that, okay. So here's my lab view expression, not my lab view, but my Excel. And so I have this perfectly fine expression here, but I gotta type it in here. I'm gonna put you away there. I'm gonna type it in here. Let's see what I'm gonna have to do. I'm gonna have to take the resistance, take the natural log of it, multiply it by a negative 25.63, and then add 84.932 to it. Right? Now, can I go through, and let me stop this over here, can I go through and do that with all these numeric things? Well, probably can, right? And I could even go into mathematics, which somebody else said I can find elementary functions, and there's gonna be trig functions and there's exponential functions, so there's even gonna be a natural log function there that I can certainly find. So I can take the natural log of my value, right, and then multiply it by those other things. But that's gonna get ugly. Is that gonna get ugly?
That we don't have the
Just-
mathematics option in the trial version.
Can we just import
With the
it?
trial version, you don't have mathematics? Well, you shouldn't have a trial version, you should have a student version.
Mine doesn't have it. I think you got it.
I've got mathematics.
I think you may be the only one that doesn't have it. You don't have mathematics?
No, because I downloaded the trial version from the
Website?
NI website, it doesn't have mathematics.
Ooh, okay, well, okay. You're gonna need to,
Yeah, I'll
Okay.
have to re-download it.
okay. Now, if we didn't wanna do those, what are the other options? Well, over here, there's this script and formula thing. So maybe we could type it in as a script, type it in equation. So we go over there and look at script and formula, and what do we see? Well, we see some things that say, oh, calculus and other kinds of things, but ooh, there's one here that says formula that has a
Blue box.
funny little blue box around it. I wonder what that does.
Mm.
Well, let's drag it out and see. What's a blue box? So it's gonna pop a wizard. Right?
It's a calculator wizard.
It's a calculator wizard, and if you look, it has an input and an output. And so you can have multiple inputs. We're gonna take E1, so our first input is E1, and what do we wanna do with it? X1. We wanna take the natural log of it. Looks like it puts the log on the other side, okay. So I'm gonna go put the cursor over on the other side and take the log. That's ln. And the parenthesis, that looks good, right?
Multiply by 25, 65.
Okay, okay, times a minus 25.63. Okay, and you see whenever it's a valid equation, it's a green light over here. When it's invalid, it changes to be some other color. And then I wanna what? Add plus 84.932. Okay, and that looks like a perfectly fine expression, and I'm going, okay. And we can get it over here. We'll take the result.